Okay, in this video, I'm gonna teach you how to create these these drainage lines in any heavily contoured map. And these are really useful to get some accurate site analysis done. So it helps you trace the rainfall direction lines and then help you place a block while you're doing a site planning or some sort of zoning. So before that, I'm going to take you out of Rhino and going to introduce you to CAD Mapper. For those of you who do not know, CAD Mapper is a tool that helps you get contour data and geographical topography data for any place to some accuracy in the world. So when I go to cadmapper.com, I'll have to make my own profile, and once I log in, if I click on try now, I can go to any place in the world. I'm going to type Bangalore, and if you really want to try contours, especially it's an already contoured site in Bangalore, it's better that you take somewhere around the lake. This is the Bellandur Lake. And I'm going to make sure that since we're working on Rhino, I'm going to click Rhino here and make sure your topography and your contours is added. 4 is the minimum or the closest that you can make the contours. So I'm just going to take this and this is fine. And once you click anywhere, you can see that up to 1 kilometer square it's free. After that you have to pay. So I'm gonna just exceed my maximum and take like 0.99 kilometer square, whatever area I get. Once that is done, I can go to create file, and it will generate these views that you see in a bit. Your everything from your 3D to 2D and topography, and I can download it. Now, once I download that, I will get it in the form of a zip file, and I can extract that to my desktop. And this is what I have, something already here, and I can go to uh, a fresh Rhino file and import it. Right. So I already have a file imported here. And before we jump into Grasshopper, let's look at the actual logic that we're gonna do to define those drainage lines. So what is happening is that if I have a section of a contour or a contour or a sloped surface, I'm going to put or extract some points on this surface. After that, those points I'm going to move downwards, let's say by 1 meter each or something. Okay, once they have moved down all to the same distance, I'm going to use something known as closest point. Now there is line closest point or curve closest point, which means that if I have a curve and I have a point here, the component is going to find the closest point on this line, the closest point to this one. If I have a surface here or a mesh here, and my point is somewhere outside or somewhere under it, it's going to find the closest point on the surface. Okay. So I'm going to use surface closest point or mesh closest point depending on our geometry. Now, if you look here, it gives us under properties, it gives us a mesh. So that means we have to use some component called mesh closest point. So anyway, uh, once this is there, once I've moved it to minus z something, I can use mesh closest point, and my closest point will be somewhere here, and my point, the new point will come here. That means my point effectively has moved. Now this one, when it goes down, it moves here. So this point has come here, and this one comes somewhere here. So this point has moved here. So we need to keep doing as effectively as kind of moving points from top to bottom, right? And for that is where the looping plugin comes to picture, which is Anemone or Anemone. So let's see how we can actually use this. This is our major uh, algorithm, and let's see how we can actually get contour lines through Anemone. Sorry, not contour lines, but drainage lines. So let's get started. We're going to feed a mesh, right? And right click here and feed it inside. Now we're going to get points. We need points of this mesh. Now every mesh has uh, four or three edges. You can see here it's a quad mesh. So a quad mesh has four edges. Each area is called a face. This is a triangulated mesh face. This is a quadrangulated mesh face. And each of the face corners are called vertices. Okay, so here I need these vertices. Basically, I need to deconstruct the mesh. So if I feed it here, I will get the vertices, and this is what I need. Okay, now I have to move it down. So move, and you can see this has moved up, but I need to move it down. Just use unit Z and negative, and I'm gonna be using, let's say, a value of, let's say, 2. It kind of moves down. I think we can increase it to a little bit more. Okay, and now once I have these moved points, now this point might move down, but it might sort of align to a closest point which is not exact this point. Let's see in a bit. Okay, now there is something known as mesh closest point, which takes the point itself and which takes the mesh. So for that, the mesh I'm going to feed it here, and the point I'm going to feed here. Now you'll understand what's actually happening. If I click on the actual point was this. Okay, the moved point is this, and the closest point is still a bit off. Now if I zoom in really closely, you'll see that the actual point is this. It goes, and then it goes down, and then it moves. So your surface is somewhat like this. To exaggerate it, this is your actual point. Then it goes down, which is this, and then it goes to the closest one, which is always going to be something like this, right? Which is this one. So this is what's effectively happening, and we want to just loop it. So this is our essence of the logic that we're going to do. Now the simple thing is, in Anemone, you will see Anemone, I have these letters, you might have something else. But basically it's just very few components. You might have a few more tabs here, but I'm going to go to utilities and going to add loop end and loop start. Okay, and what I'm going to do is, first of all, connect this to this, and within this data I'm going to play whatever I want to do. And the first iteration, I will feed in this data, the number of iterations is count, and the trigger is a button. So I'm going to go for, let's say, 50 iterations, and my trigger is just a button. It's this on switch, and my data is this. Okay, and apart from that, I'm also going to be using the counter, which just tells me that how many iterations uh, is my counter running. Right now it's running 2. I don't know why, but let's just connect the data. Now this is where it gets complex. I will disconnect this, and I'll feed this here, and the output, the point, I'll feed in here. Now this is very important. We are feeding the first iteration of the points here, and out of the data we are getting the output of the moved points for the first iteration, then moving it to the closest point in the mesh, and then the loop repeats. So it goes down, comes back to the surface again goes back, right? Again goes down, and then it sort of repeats. So this effectively is happening. The point kind of moves, right? Uh, and finally, we can see that if I switch this on, you'll see that the point's moving actually. And you'll also see the counter. A counter is 50 iterations. Let's put it 100 and see what happens. You see the points moving to areas where you will have the lowest part of the drainage. Let's switch off everything by Control Q. Okay, I only have this on, and if I refresh this using the button, you can see the points actually moving. Right now, adding on one more step to this is if I could make a line out of this. So first of all, I'll right click here and go for record data. So it will record each and every iteration. And after that, what I can do is, yeah, it's important to flatten here so that each line becomes a set of its own. And then you can see that these become a line. If I do not flatten, they all, for some reason, act different. You can see the set data here. Okay, yeah, this is fine, actually. Yeah, right. This is a fresh new data. You don't need to flatten, just ignore that. Cool. Now I have this. Can I interpolate? Now the problem here you'll see is you'll get a line, and since this is something that I don't want, it's going everywhere. So I need to flip the matrix. And you can see if I switch this off, you can see the actual lines coming in. I can reduce the number of iterations for now to make it a little faster. Let's say 40. And you can see these lines, the counter starts running and these lines start generating. Okay, so this is extremely cool. Now you can always have all these curves baked so that you get that line. Another very cool thing is if instead of a mesh, you had to do this with a surface, like a surface that you build using anything that you sort of want to have a 4-point surface, you rebuild it, take points on, and sort of have any kind of this uh, heavily contoured, heavily sloping surface. So uh, there is not much difference in the code, but the only thing is I have this code here. You have to take the surface itself and you have to use divide surface so you get these points. And the points will come in a set data, so you need to flatten it. And that's the only thing. Apart from that, instead of the mesh closest point, you'll have to use surface closest point. And if you see what happens here, you can see that these were the original points, these were these points, and if I refresh it and you see the lines moving, I'll switch off these, you'll actually see the points. Now I can bake this to get your actual contour lines. If I switch this off, you'll get these contour lines. I can always hide this. So this kind of helps that this is your flat area, this is your flat area, and this is super flat. So where you can actually place your buildings and it will be less prone to flooding. So yeah, this is where you can use Anemone